Good morning, good evening, wherever you are in the world. My name is Sarika Parekh, and I'm the Worldwide Market Manager for Db2 for ZRS. Today we have one of the world's experts on Db2 for ZRS, and he'll be sharing his knowledge and experience around Db2 11 migration planning. John Campbell is an IBM Distinguished Engineer. Towards the end of the webcast, there'll be 15 minutes for live Q&A. You can follow John Campbell on Twitter at GuruDB2.
Hello, this is John Campbell here. I'd like to give you my own personal welcome to all the people attending today's webcast. The subject for today's webcast is Db2 11 for ZOS migration planning and early experiences, and today we're going to cover part 1. Now let's turn to slide 3. On slide 3 here is information about the IBM standard disclaimer about product information and trademarks. Now let me turn to slide 4. On slide 4 here are the objectives for today's webcast. First of all, I'd like to share lessons learned, surprises and pitfalls from the early customer migrations, provide you with some hints and tips so you can achieve success, address some myths that may have grown up regarding Db2 version 11 and admit or outweigh those, provide some additional planning information that's not readily available in our standard documentation, and when it comes to the new enhancements in version 11, provide you with some usage guidelines and positioning on how to use these. But my overall objective here is to help you as customers migrate as fast as possible, but also safely to this new release. Now let me turn to slide 5. On slide 5 here is the agenda for today's webcast. So I'm going to start by covering an introduction in terms of the features of this release, and then I'll work my way through these other topics as you proceed through part 1 of the webcast. Now let me turn to slide 6. On slide 6, I'm going to cover an introduction to version 11. Now let me turn to slide 7. On slide 7, I'd like to introduce and discuss the 4 major themes of Db2 version 11. The first one is out-of-the-box CPU savings. This would obviously improve efficiency and help reduce performance cost. And we've tried to introduce these performance improvements transparently. In other words, there's no need to make application changes or to change the SQL used by the applications. And we've carefully targeted here complex query. But what we've seen here is a broad set of performance improvements across complex OLTP, update-intensive batch, and queries. The most you have to do as a user of static SQL is to rebind your static SQL packages to benefit from the runtime improvements, and also to do that without AP reuse, so you can expose yourself to getting the new access path changes. What we generally try to do here is turn a lot of complex SQL that may be using stage 2 non-indexable predicates to make those stage 1 and indexable. The second major enhancement area is enhanced resilience and continuous availability. First of all, what we try to do here is introduce improved autonomics to reduce cost and improve availability. We've also continued the theme in recent releases of introducing more online schema changes without affecting the applications. In other words, changes that are stored in the catalog, and then you run online reorg to materialize those changes. There's a strong set of enhancements in the utilities area, and particularly in the area of online reorg. And we try to make online reorg much less disruptive. So there are improvements related to part-level reorg to get a better chance of getting a successful drain, and also some optimizations made to the switch phase, so the switch will actually be quicker. Some of the highlights in terms of schema changes are the ability to drop columns and to alter the limit keys of particular partitions. One of the really major enhancements has been to express the log record addressing range. And we've done that so you can now have a much longer addressing range for the log RBA and also for the log record sequence numbering data sharing. And probably my personal favorite is the ability of bind, rebind, DDL, and online reorg to break into persistent threads that are running packages bound with release deallocate. In the area of enhanced business analytics, there are incremental improvements to the SQL, DML, XML, and analytics capability. We've also enhanced our solutions for temporal and native SQL procedures and provide better integration with IBM solutions for Hadoop, together with NoSQL and JSON support. And one new feature is transparent archiving that's proved to be one of the greatest hits of version 11. The last theme here is simpler, faster DB2 version upgrades. The first subtopic there is improved product quality and reliability. And this has come about as a result of the iterative approach we've adopted in version 11, where we're following an agile methodology on 3-month rallies. And as we go through each cycle, each rally, we're actually doing a full cycle of functional, system, and performance testing, and also getting the high-impact defects fixed before we move on to the next 3-monthly cycle. And we also stabilize the code ahead of starting our early support program. Another feature which is very important is that we have this new feature called Application Compatibility, or APPLCOMPAT for short, and this gives you the ability to migrate faster than new release, because what it does is it divorces application changes that are needed for incompatible changes from the actual system upgrade itself. It doesn't mean you can avoid dealing with the incompatible changes. It just means you can do it later, for example, after you've migrated to new function mode. And the last subtopic here is improvements in the area of access path stability. Now let me turn to slide 8. I'm actually now going to talk about the highlights of the early support program. Let's turn to slide 9. On slide 9 here is a summary of the customer feedback from the version 11 early support program. Many of those customers have participated in many early support programs, and they reported very much improved quality and reliability at this early stage in the release cycle. We also got good validation on our performance and CPU savings in this release. And we saw healthy double-digit CPU reductions across DRDA, kicks, and batch workloads. On the second half of this chart are what I call the greatest hits of version 11. These were functions and features where customers spent most of their time during the early support program evaluating. And these same functions and features are also the things that are driving people to early migrations to version 11. The first one is bind, rebind, DDL, and online reorg, being able to break into persistent threads running packages bound with release deallocate. Many customers, as a result of version 10, are now able to make much more use of persistent threads such as IMS pseudo-WIFI and kicks protected entry threads, and they're coupling that by running packages bound with release deallocate, and they're getting healthy CPU savings. But unfortunately, bind, rebind, SQL DDL, and online reorg does not use drain and claim mechanism, and therefore the shared lock held by the packages running as release deallocate are blocking these types of activities. So we have a new autonomic capability that allows these types of command, DDL, and utility to break in. We have a feature called Transparent Archive, which makes it very easy to extend existing applications to keep history and allow new applications or even existing applications to be extended to be able to have a combined view of the current active data and also the history data. IFCID 306, which is used by queue replication and similar tools, now has the capability where the calling application can provide a list of objects. And this filtering can then be done inside the DB2 engine. And this means there's less traffic across the IFCID 306 interface, and it also means that less log records have to be decompressed. In the area of online schema evolution, you've now got the ability to drop columns and also change the limit key on partitions. And again, the schema changes goes pending and stored in the catalog, and then an online reel is used to materialize the change. There's a long list of utility improvements, particularly in the area of online reorg. And a lot of those nice improvements are related to when you're running reorg at the partition level against one or more partitions. You've now got a much greater chance of getting a successful drain, and also the switch phase has been re-optimized so that the duration will be reduced. We've made a fairly fundamental change here, moving from a 6-byte to a 10-byte value for log RBA addressing, and also the log record sequence number as used by data sharing. We've done this for several reasons. First of all, many customers have exhausted or approaching exhausting the log RBA addressing range of a non-data sharing system or one or more members of a data sharing system. And a tiny number of customers have exhausted the LRSN addressing range of the data sharing group. As part of the solution, as part of this 10-byte value for the LRSN, we've provided more precision on the low order, and that means we can eliminate LRSN spins for data sharing customers. Also, the improvements in query optimization and the improvements of migration have been welcomed by our customers. We provide group-by-grouping sets. We did this in support of the SQL cube and rollup function, but it can also be used outside of that. So in one group-by-query now, one can specify multiple group sets, and this can be satisfied in one scan of the data. Now let's turn to slide 10. What I'd like to do now is through the migration consideration. Let's turn to slide 11. On slide 11 here are a list of the hardware and software prerequisites. None of these are particularly onerous, but I will highlight a few items. First of all, the amount of real storage required when migrating from version 10. This is a fairly common question. The good news here is based on our early customers migrating to version 11, any increase in real memory is very modest. And I've said on the chart here, plan for up to 15%. That's a very conservative number and a fairly safe number in terms of estimated increase in real storage. The second item I'd like to highlight is the level of IBM InfoSphere data replication that's required. We often refer to this as IIDR for short. You have to be on at least 10.2.1 even for conversion mode. On the next slide, in the next two slides, I'm going to go into some detail about DB2 Connect. But before I leave this slide, I do want to point one thing out. The early code on any DB2 release is compatible upper level and down level, in other words, plus or minus 1. However, I've seen a number of customers who, by accident, are running with the version 9 early code. The good news is that 99.9% of the time this works, but in a small number of cases, this may cause serious errors. So we've brought out a relatively recent APAR PI 23400 that if it detects version 11 is running with the version 9 early code, it'll generate a warning and shut down DB2 softly. Now let's turn to slide 12. On slide 12 here and the follow-on slide, I'd like to talk about the prerequisites in terms of DB2 Connect. DB2 version 11 in all modes should operate with all existing versions of DB2 Connect as far back as DB2 Connect version 8. However, bear in mind that version 8 is not in service any longer. If there is any breakage, then if the issues are related to connectivity and that these can be fixed on the DB2 for ZOS server side, we will try and provide a fix for you. However, if the issue is with the DB2 Connect server or the DB2 Connect client or the data server driver, you will have to move to a supported level, and even if you're on a supported level, you may have to move to a higher fix pack or move to a special build. Now, if you're a customer who really wants continuous availability and wants to perform an online release migration, then we have some recommended minimum levels. And the recommended minimum level for leaving version 10 to go for version 11 is version 9.7 FixPack 6 and version 10.1 FixPack 2. These were levels that went through extra testing at the DB2 Silicon Valley lab, and these were all based on using the data server driver to connect to the back-end data sharing group without going through a DB2 Connect server. These are the levels that provided the best continuous availability across an online release migration. Most of the DB2 features that are new in DB2 version 11 and available in NFM are supported with any version of DB2 Connect, apart from 4 specific features. Now, these 4 specific features are now listed on the bottom of the slide. This is the array support for native SQL procedure, the workload manager support for global variables, the performance improvement related to auto commit, and the new longer client information fields. If you have those 4 specific features, then you need to be on at least 10.5 Fixed Pack 4. Please bear in mind that this level will probably go over time as customers have experiences, as we roll through best practices, and when defect fixes are rolled out to new driver levels. Now let's turn to slide 13. On slide 13, we in DB2 for ZOS development have been very proactive in recommending customers to move away from the client and runtime client packages going through the DB2 Connect server gateway and actually migrating to the DB2 server drivers instead, where the data server drivers connect directly to the back-end data sharing group. A common question I get asked is about what is the recommended best practice in terms of upgrading the DB2 Connect infrastructure. And taking the general case here, the first thing to do is to upgrade DB2 for ZOS server from version 10 to a version 11. If you are using the DB2 Connect server, to upgrade that next, although as I said, we are encouraging the direct connect from the application server directly to the back-end data sharing group, and then to upgrade the drivers installed on the application servers. And again, what we're trying to get you to do is to move away from the runtime client over to the data server driver, and then finally go around the end user workstations and again migrate to the data server driver. There are always exceptions, and certainly with customers using Microsoft application serving, generally speaking, these customers tend to want to use the new drivers first because they want to take advantage of the new application enhancements. So you may have to adjust this recommended best practice here to support your individual installation. Now let's turn to slide 14. On slide 14, I want to discuss pre-migration planning. There's a job provided with both version 11 and version 10, which you should run to identify incompatible changes. So on version 11, this job is called TIJPM, and this checks the situations requiring attention. This same job is actually shipped with version 10. It's called TIJPB, and this enables you to get a head start whilst running on version 10 to run this job, identify the incompatible changes, and to clean up earlier before you migrate to version 11. Now let's turn to slide 15. On slide 15 here, I'd like to provide some important information in terms of preparation. As you migrate to newer DB2 releases, you will find that old plans and packages are being deprecated. In other words, they're invalidated and must go through auto-bind. And we're doing this for several reasons in the DB2 product. First of all, it simplifies our code. Secondly, it improves performance. And it also reduces your exposure as a customer to threader bans in core out. Specifically in the case of version 11, plans and packages that were last rebound prior to version 9 will be invalidated and go through auto-bind at first touch under version 11. My advice here is to avoid this. And having identified old plans and packages under version 10, you should explicitly rebind these plans and packages under version 10 before you go to version 11 to avoid the invalidation and the auto-bind. And also in the terms of the packages, this means you can use APVuse when doing the rebind under version 10 to protect the access plan stability. Also, if you're using temporal support, any views, MQTs, and table functions with a period specification must be dropped before you go to version 11. Now let's go to slide 16. On slide 16 here are a list of items which are previously deprecated. That deprecation was announced under earlier versions. This list of items are now eliminated in version 11, and any use of these must be eradicated before you migrate to version 11 conversion mode. Let's now turn to slide 17. On slide 17 here, I'd like to introduce and discuss the new feature called Application Compatibility, which is referred to as APPLCOMPAT for short. The genesis of these customer requirements came from the version 10 migration, when there was some undocumented, incompatible changes which hit a significant number of customers. Ultimately, it resulted in a new ZPARM called BIF compatibility, and where the default value reinstated the previous version 9 behavior. What customers told us is, first of all, they want a mechanism whereby they can do the DB2 system migration, migrate to the new release of DB2, and deal with the incompatible changes over a more relaxed time frame. Secondly, they asked us for a mechanism like a trace, which would identify those specific applications that were affected and which needed to be investigated. And thirdly, they wanted a mechanism whereby they could fix up these incompatible changes on a program-by-program basis, including in a mixed DB2 release coexistence in data sharing, and also enable support so they could phase in these changes over 2 releases of DB2. So the end result of this is a new feature called Application Compatibility, which divorces or separates the DB2 system migration to the new release of DB2 from making the application program changes to deal with incompatible SQL, DML, and XML changes. Now let's turn to slide 18. On slide 18 here, I'd like to provide some more detail about the implementation. First of all, there's a new system parameter ZPARM called APPLCOMPAT, and that provides a system-wide default for the behavior of bind and rebind. In the context of version 11, there are only 2 values. Version 10 R1 gives you the version 10 SQL, DML, and XML behavior, and version 11 R1 gives you the DB2 version 11 SQL, DML, and XML behavior. For new installs of version 11, the default will become V11 R1, and if you're migrating from version 10 to version 11, the default will be V10 R1. The APPLCOMPAT option is also available on the bind and rebind commands, and whatever you specify on the bind and rebind commands will override the ZPARM default. For dynamic SQL, you can control the version 10 versus version 11 behavior by setting the current application compatibility special register or using DSN profile attributes. One thing I want to draw your attention to is APPLCOMPAT is really just about SQL, DML, and XML behavior. It doesn't control issues related to new reserved words or access path changes, etc. The BIF compatibility ZPARM that was introduced in version 10 still exists, and it operates independently of APPLCOMPAT. The BIF compatibility ZPARM will be continued to be supported going forward until such point that any deprecation is announced. A very key point here is you can't use any new SQL, DML, or XML functionality in V11 NFM until the application is running with an APPLCOMPAT of V11 R1. So when you actually rebind an application or replace an application with an APPLCOMPAT of V11 R1, first of all, you're certifying that you've cleaned up all the incompatible changes that may exist. And secondly, it's a prerequisite to using any new SQL, DML, or XML functions. On slide 19 here, I'd like to provide some more detailed information about APPLCOMPAT. When you actually migrate into V11 CM mode, APPLCOMPAT will be set, ZPARM will be set to V10 R1, and that obviously will happen prior to NFM. If you try to set the ZPARM APPLCOMPAT to V11 R1 whilst you're in V11 conversion mode, you will get an error, and a DSN T225 message will be generated. there are two IFC ID records that you can use to identify programs that need to be investigated and possibly fixed up. The first of these records is IFC ID 366. This is the first trace record we produced, which will give you detail on version 10 function usage, which is incompatible, and it will identify the packages. However, IFC ID 366 is quite voluminous in terms of the output it generates, and it's quite cumbersome. And you're better off ignoring IFC ID 366 and focusing on IFC ID 376, which continues to be enhanced and provides you a condensed summary of packages which use functions that need to be investigated. In terms of the spirit of this requirement, we expect you in the life of V11 NFM to actually clean up any incompatible changes and to switch your system parameter over to V11 R1. But that's not mandatory, and you have up to 2 releases to clean up the incompatible changes. Now, a point on usability here, a number of customers wanted the ability to distinguish between packages which hadn't yet been rebound under version 11 from packages that were rebound AppleCompat V11 and broke and had to be rebound and fall back to V10 R1. So one thing you can do is annotate the package by using the SQL comment on package command, and that comment will be stored away in the remarks column in the catalog table called syspackage. And then you can run queries against the syspackage table to identify those packages that would not work under V11 R1 and had to fall back and be rebound to use AppleCompat V10 R1. Now let's turn to slide 20. As I said earlier, the BIF compatibility ZPARM continues to be supported and operates independently of the AppleCompat ZPARM. So in version 11, in all modes, we still support BIF compatibility V9 and BIF compatibility where it's set to V9 decimal varchar. But there's one little twist on that that's important. Under version 10, we continue to provide support for invalid timestamp formats. Now, let me be very clear about this invalid timestamp forward. We never documented or never intended to support this invalid format. However, we did support it indirectly. And we continue to support it in V11, but only when you're running with AppleCompat V10 R1. If you're using this undocumented, unsupported timestamp format, you must clean it up before you bind with AppleCompat V11 R1, or the application will break. Now let's turn to slide 21. On slide 21 here is a diagram that gives you an overview of the overall migration process from version 10 to version 11. This picture is pretty much the same way as it was from version 9 to version 10. But what I do want to draw your attention to and overlay on top of this is just to reinforce the message about application compatibility. So whilst you're running in conversion mode, the only option at the ZPARM level or on bind and rebind is to use AppleCompat V10 R1. However, once you've got into version 11 NFM, you have the option at the individual package level of either specifying version 10 or specifying version 11. So if you specify it on the bind, this will override the system parameter, the ZPARM. And at some point, you can actually flip the ZPARM, and that will become the new default behavior on new rebinds and bind replaces. However, the AppleCompat is a sticky option. So if you have specified a value for AppleCompat, that will still override the ZPARM. Now let's turn to slide 22. On slide 22 here is a picture which summarizes the migration and fallback paths. The process, again, is very similar to what you had in version 10. But with version 11, you can always drop back to the previous stage. You cannot drop back to the older release after you've submitted the ENFM job, but you can always return to conversion mode, and that will be flagged as CM star. One thing that is different in this release is that the catmate jobs, which are the JTC and the JEN jobs, they will not execute if there are any entries in sys2 util-x. So if you've got any failed utilities, you need to terminate those and clean up before running the migration. What Db2 used to do previously was blindly basically reinitialize sys util-x. We will no longer do that. What the picture shows here is the various steps, including the fallback steps, and the job names that are used at each stage. Now let's turn to slide 23. One thing that Db2 checks before migrating is that you have the fallback SPE APAR and the prerequisites applied to your system. This applies to both a non-data sharing and also a data sharing system. So you need to look at the info APAR, AI14660, and Db2 will check on the migration that the right prerequisites are actually in place. So if it's data sharing, you must apply it to all members of the data sharing group before starting the migration. Now let's turn to slide 24. The next topic I'd like to talk about is what I call pre-migration catalog migration testing. And I feel this is a very important topic here for mitigating risk and being able to demonstrate that you've mitigated the risk in migrating to a new Db2 release. Let's turn to slide 25. The basic idea here is to give yourself the chance to actually practice the migration in a non-production environment and confirm that everything is working okay. So the objective here is to mitigate risk and be able to demonstrate that you've mitigated the risk inside your organization. And I strongly recommend this as a way of achieving a successful migration of the production Db2 system. There are two options. One is to actually clone the production Db2 catalog and directory away into a separate environment and to practice there. Or the other option is to exploit your DR or BCP environment and to practice over there. So the rest of these charts here on this topic are all related to cloning the Db2 catalog and directory. And there's various techniques or options that you can use to clone the catalog and directory. You could run copy share level change in a quiet period when there's no binds or no DDL, or you could use flash copy image copies or any of these options listed on this chart. Now let's turn to slide 26. So what we're trying to do here is just clone away the catalog and directory, not the logs and not the application pay dates, just the catalog and directory. And once we've actually established that in a different environment, then what you can then do is run the following list of health checks against that catalog and directory before you start to flush out any latent data inconsistencies before you do the actual migration in production. Now let's turn to slide 27. Now, having actually established this environment, the then idea is to practice the migration. Practice, the first catmate when you start the version 11 member, then run the v11 ENFM process. And what you're able to do here is to make sure you have a good working set of JCL. There are no errors. That you get an estimate as to how long it's going to take, and you feel confident about running these same jobs in production. It also gives you the opportunity to rebind plans and packages and to do access path validation, and also explain the views as well and check the access path selection. It also, if you want to, is you can engage other parties in this process like DBAs and application developers so they can try out some new features, and ultimately you could extend this testing to include the application objects and do some application regression testing. Now let's turn to slide 28. Now on slide 28 here is a picture which I'm not going to dwell on for too long here, which takes you through the various steps here, starting with taking the image copies as share level change in the production system, then preparing the target system by deleting the structure and data sets, and then going through all these various steps here in order to cold start the system in a non-production environment and get yourself ready to practice the migration. Now let's turn to slide 29. So the next major topic I'm going to start talking about are the key enhancements related to improved availability. Now let's turn to slide 30. On slide 30 here, I'd like to talk about a new autonomic feature which allows bind, rebind, SQL, DDL, and online reorg to break into persistent running threads which are running packages bound with release deallocate. And let me start by explaining what the problem is. When you've got persistent threads running packages which are bound with release deallocate, then there will be a persistent shared mode lock on the package. And when you try to run these types of activity, they will be blocked by that persistent shared lock on the package. Now, many of you may be puzzled at this stage about why I'm talking about online reorg in this context. Normal online reorg, since version 5, has always been able to break into persistent threads running packages at release deallocate. But the difference is, in version 10, we allow these pending alterations. And some of these pending alterations, which are materialized with the online reorg, require the packages to be invalidated. And it's those types of online reorg which result ultimately in packages being invalidated that will not work under version 10. So when you have persistent threads, they may be KICS protected entry threads or IMS sudo WIFI. These are the types of threads, when running release deallocate packages, that will actually block these types of activities coming in. And types of reorgs which invalidate packages are things like reorg rebalance, which are now in version 11, you can run a share level change, and also the materializing reorgs, some of those will invalidate packages. The new break-in behavior is autonomic. It's on by default. It is controlled by a ZParm called package rel commit. The default is yes, and you could set that to no if you wanted to disable it. The actual break-in mechanism is performed on a best efforts basis. And the break-in mechanism does depend on the fact that it will find idling threads at a transaction boundary. In other words, the last thing those threads was either a commit or a rollback. So it's somewhat similar to online reorg. You have to have threads in a consistent state at a boundary in order for them to break in. Now let's turn to slide 31. There are several factors that come into play in order to get a successful break-in. First of all, the persistent threads must commit or even roll back. Also, the timing of the commit and the frequency of the commits are both key. And also, your setting for the IRLM resource timeout interval, IRLM RWT, also has a role to play. The greater the value, the greater the chance of success in breaking in. On the other hand, if the value tends to be very small, you've got a reduced chance of being able to break in. There are some types of features which will still prohibit the break-in mechanism. So, for example, if you're running packages bound with keep dynamic yes and you issue dynamic SQL, or you have open held cursors which are open at commit, or you have commit inside a stored procedure, any of these three features will stop the break-in mechanism for work. But I should also point out that these same features would also block breaking into a thread where the packages are release commit. So there's no new restrictions here. It's just exactly the same restrictions that you would get with release commit. Now let's turn to slide 32. On slide 32 here in the follow-on slide, I'm going to take you through the various stages or steps in the break-in mechanisms. And one underlying principle here, in terms of how this is going to work, is what we're going to do here is commit on the threads, deallocate the thread, and then reallocate the threads with the packages running as release commit. And when the bind, rebind, SQL, DDL, or online reorg is finished, then we'll switch the package release option to be deallocate. So what happens at step 1 is the bind, rebind, DDL, or the online reorg, which is materializing a change, will try to take an exclusive lock on the package. And that will collide with the S-mode package lock that's held by the persistent thread. And what will then happen is these types of activities will wait behind the S-mode package lock, and if they can't break in, they will time out at 3 times the IRLM timeout limit. At step 2, which will occur at half the IRLM timeout interval, DB2 will get notified by IRLM that someone, the bind, rebind, etc., is stuck on the package lock. And DB2 will look to see if he is the S holder, in other words, the shared lock holder. In other words, the thread is holding the S lock. And at that point, DB2 will then post a system task to take further action. At step 3, this system task will be woken up, and it will check to see if a recycle of the locally attached threads has been done in the last 10 seconds. If not, the break-in mechanism will proceed to step 4. This is a defensive mechanism here, because what we want to do is avoid battering the system to death with wave upon wave of recycles. Now at step 4, a broadcast message is sent to all the DB2 members of a data sharing group, because each member of the data sharing group will ultimately have to perform a recycle of all the locally attached threads. At step 5, each member, operating independently, will loop through all the locally attached threads and see if they were last committed or aborted in greater than half the IRLM timeout interval. If this is the case, it's highly likely that the bind, rebind, DDL, or online reorg is waiting on them. At step 6, the next test is to see if those DB2 members can do anything about it. So it will check to make sure that each thread is at a transaction boundary. In other words, the last thing the thread did was a commit or an abort. And if so, then DB2 can then proceed to process the threads. Now let's look to step 7 on slide 33. At step 7, DB2 will fence the SQL API for the thread, grab the agent structure, and drive a dummy commit. This commit is transactionally okay, since we're at a transaction boundary, and we previously checked that at that thread, the last thing that was done was a commit or a rollback. The commit itself will be a single-phase commit, and with DB2 being the coordinator. On the commit, DB2 will see that there is a waiter for the package lock held by the agent and switch to release commit for the commit cycle. The lock is freed, and DB2 is now one step closer to success. On step 8, this will be repeated for all qualifying threads. At step 9 now, the bind, rebind, DDL, the online reorg should be able to break in, provided all the blockers are removed. Now, it's possible that not all the blockers may be removed, because there may be some long-running read-only applications that never commit. But assuming everything is okay, through the recycle processing, the APIs are blocked, DB2 will spin on the thread in a time loop until the recycle is done. The application will wait a millisecond approximately between polls, and DB2 will also take care of abnormal conditions like cancelling application TCBs or end of memory, etc. Now let's turn to slide 34. On slide 34 and the follow-on slide, I'd like to share with you the results of customer testing. On slide 34 here is a very simple test case here. It illustrates a single persistent thread. In this case, it's a KICS protected entry thread. The same could apply here to an IMS pseudo wait for input region. So you have a thread which persists, and time here is going left to right, and you have a transaction running on the thread. The transaction commits and finishes, and then the thread is idling, waiting for new work. And then after that, the bind comes in, is able to break in successfully. The bind had to wait approximately 30 seconds before it's able to break into the idle thread and run successfully. So very important consideration here, illustrated by this test case. This new break-in mechanism doesn't just deal with active threads, it also deals with persistent threads that are idling, waiting for new work. Now let's turn to slide 35. On slide 35 here are a list of test cases that the customer ran, and it also documents the results. So the first test case is a bind trying to break in into a batch probe that runs for a very long time without a commit, and the result was no break-in. So this illustrates that you have to frequently commit or roll back in order to break in. They then repeated the same test case with the batch program that commits frequently, and they were successfully able to break in. The third test case was where they were running 50 concurrent KICS protected entry threads, and again the bind was able to break in. And the final set of test cases where they were running various types of SQL DDL from create index all the way through to alter petition, and this type of activity was able to break into a KICS protected entry thread. Now let's turn to slide 36. The next enhancement I'd like to talk about is alter limit key. And the behavior of this new function depends on how the table partitioning is controlled. What I mean by that is it could either be table control partitioning or index control partitioning. In version 11 with a table controlled table partitioning, this is a new type of pending alter. And basically then the actual materialization of the pending alter is done by a subsequent reorg. However, if it's index-controlled table partitioning, then you have to pay serious attention here, because if the alter is done via alter index, alter partition, the partition goes into hard reorg pending. And this condition cannot be withdrawn, so you have to run the reorg. You could equally do it against an index-controlled table by using alter table, alter partition. And again, if the partition is not empty, there's some data in it, the partition goes into hard reorg pending. The good news is it's converted to table control partitioning, but the reorg pending condition cannot be withdrawn and a reorg has to be run. And the only blessing is if the partition is empty, then the alter is executed immediately, but again the table space is converted to table control partitioning. So UTS table spaces always use table control partitioning, but with classic partition table space you can either be using table controlled or index control partitioning. And so the question that you must have there is, how do I convert from index control to table control? And probably the easiest way to do it is to identify your partitioning index and do two alters within the same commit scope. Alter that index to be not clustering, and then alter that table back to be clustering, and that will convert your table space from being index control partitioned to table control partition, and it will do that without putting the object into a restricted state. Now let's turn to slide 37. Two new EPALMs have been introduced to help this situation. The first EPALM, called Prevent Alter TB Limit Key, when that's set to yes, this will stop any alter table alter partitions, and if you try to do this you'll get a negative SQL code 876. And the second EPALM, Prevent New Index Control Part equal to yes, this will stop you being able to create new index control partitions. So this will ensure that all new partition table spaces created going forward will be using table control partitioning. The good news about this enhancement is that you can then run a materializing reorg that will be able to break in even to a persistent thread running packages which are bound with release deallocate. When it comes to reorg rebalance, this will not be possible for partitions with pending alter limit key changes, but it will work for the other partitions. And reorg rebalance will also work for partitions that are already in hard reorg pending, in other words, the reorg P condition. Now let's turn to slide 38. The next enhancement I'd like to talk about is drop column. This function only applies to universal table space. It does not apply to the classic table space types, simple, segmented, and partitioned. And once you're at UTS, then you can do the drop column. And in fact, you can combine the conversion to UTS and the drop column in the same materializing reorg. So you can put an alter in of seg size to convert to UTS, which will go pending. And then you can put in a drop column, which will also go pending, and then run a single materializing reorg, which will actually implement both changes, both the conversion to UTS and actually drop the column. The materializing reorg can operate at the partition level, but all the partitions have to be covered. And please notice that all packages touching this table will be invalidated and have to go through autobind. On the second half of this chart are a set of obvious restrictions, like you can't drop a column on a classic partition table space, and etc. And what you have here is the various negative SQL codes and the negative messages associated with it. Now let's turn to slide 39. Set of slides, I want to talk about the utility enhancements in version 11. Now let's turn to slide 40. On slide 40 and the follow-on slides, I'm going to be introducing and describing the REORG enhancements. The first enhancement is that you've got a better chance of achieving a drain on a part-level reorg and a faster switch phase. The better chance of achieving the drain is particularly important if you're running a part-level reorg against multiple partitions, because previously what DB2 would do is drain each part serially, and the danger is that the drain of the parts would time out based on drain weight, and therefore the reorg would fail. Now what DB2 will do is set the drain controls on all the parts involved in that part-level reorg, and that means the drain should be quicker and more effective, and a greater chance of proceeding to the switch phase. The other enhancement is related to the switch phase itself, and this code has been optimized now to reduce the number of data set opens and closes, and therefore the switch phase should be faster. A number of customers run the reorg with max RO defer, and then they put in an alter command later to alter the utility to proceed to the last log iteration of the switch. So this involves a two-step process. Well, now there's a new switch time option on a reorg which avoids this two-step process, and therefore it should be operationally a lot simpler. When you're actually performing a reorg against multiple parts or even an individual part, previously DB2 used to create a full image copy of the whole table space. Now when you're running part-level reorgs, the reorg utility, when it creates an inline copy, will produce an inline copy at the part level. Now, tape support is provided, but there's no support yet for stacked tapes, and that needs a solution from the ZOS side. To actually make this work, some changes are made to existing jobs. The second half of this slide is a new sort data no option, where you can also say recluster no. And what recluster no does is it bypasses the sort. And what it's trying to do here is speed up the conversion to extended log RBA LRSN format, because in order to get to the extended log RBA and LRSN format, you will have to reorganize all the objects. So the idea here, if the objects are pretty well clustered, if you can have an option like this that could potentially speed up the reorg, that would make that conversion a lot easier. However, in reality, results have been mixed in this area. Now, if the index key is much smaller than the data row length, this may save quite a bit of processing. But so far, customer experience has been mixed. Next point I'd like to say that recluster no is enforced for reorg share level change with sort data no. If you really want reclustering, you need to specify sort data without no. And there's a new message, DSNU2904I, which gives you the unload method that's being used by the unload phase of reorg. Now let's turn to slide 41. On slide 41, I'd now like to talk about the automated building of the mapping table with the new 10-byte log RBA LRSN value. And there's a difference in behavior between CM mode and NFM mode. When you're in V11 CM, the behavior is as follows. Any existing mapping table, whether it be in version 10 or V11 format, will be reused. If the mapping table does not exist, a mapping table will now be automatically temporarily created. The difference between the version 10 and the version 11 format of the mapping table is very slight, very small. And the only difference is that the size, length of the LRSN column has increased from 6 bytes to 10 bytes. In version 11 NFM, the behavior changes. If a mapping table already exists and it's in the V11 format, then it will simply be reused. If the mapping table exists but it's in the version 10 format, the existing mapping table will be ignored, and a new mapping table will be automatically created in the same database as the original mapping table. If the mapping table simply does not exist, the mapping table will be automatically temporarily created in the database specified in the ZPOM, or in the declared database, or in DSN DB04. In terms of recommendations, my primary recommendation here is to predefine and keep the mapping tables around for regularly scheduled reorg jobs to avoid SQL DDL contention on the DBD and the catalog. Use a single specific database as specified by the ZPARM for all your mapping tables. Modify the schema of the existing mapping table to the V11 format with a simpler alter table example that I've shown on this chart here, where you simply alter the table, increasing the size of the LRSN column to 10 bytes. And this last point here is to wait for the PTF for APAR PI 08339 if you want to automate the building of the mapping tables. Now let's turn to slide 42. On slide 42 here, I'm continuing on the theme of the reorg enhancements, and the first thing I want to talk about is a new option called Drain All Parts Yes. And this has significant potential to reduce outages. What it tries to do here is avoid deadlocks between drains and claims across MPIs and partitions when you're reorganizing a subset of the partitions of a partition table space. The solution involves momentarily draining all the partitions on the table space, not just the partitions that are being reorged. With this approach, we're more likely to be successful in getting a successful drain to make the switch. And what we've seen here and experienced is big reductions seen in the elapsed time to complete the drain and the switch, and reorg should be able to run with less problems using this feature. There's a new message in reorg, DSNU 1138I, which provides information about at the timing when the drain begins and ends. You've also got a keyword called parallel, where you can control the number of subtasks. You should be aware that there's a change in some of the defaults for reorg discard. So, for example, Notepad Yes is now the default. And finally on this slide, there's a new option called Log Ranges No. And this is intended for very special use when the contents of this log range are not trustworthy. In other words, they're logically corrupted, or it has to be reinitialized. Normally, Log Ranges No will only be used under the guidance of DB2 Level 2. Now let's turn to slide 43. On slide 43, I'd like to continue on the theme of reorg enhancements. The next enhancement I'd like to talk about is reorg rebalance being able to run a share level change. And this is a major step forward for 24/7 continuous application service availability. The unload phase of reorg rebalance can now deal with one or more of these conditions. First of all, the existing partitions might be empty, or secondly, there may not have been enough data in the existing partition to build a compression dictionary. So the good news now with reorg rebalance is it will build a single compression dictionary that will get applied to all the target partitions, and this avoids the need to run a subsequent reorg later to gain the data compression. Another major point is that because the enhancement related to bind, rebind, DDL, and online reorg break-in, the reorg rebalance can now break into persistent threads running packages bound with release deallocate. In a small number of cases, you should be aware of a possible negative impact on parallel application batch processing. A number of existing applications were based on the fact that they were running multiple copies of the same application in parallel against distinct key ranges. And those distinct key ranges matched up exactly with the range of keys in a given partition. When you run reorg rebalance, DB2 itself will decide what those limit keys are. So there may be some disturbance, a negative impact in terms of the way such parallel batch processing works. The second option on this slide is partition pruning for UTS PBG table space. This is optional and it's not the default. It provides you the option to physically remove and contract the number of UTS PBG partitions. It's only performed when the ZPARM reorg drop PBG parts is set to enable. As I've said already, it's disabled by default, and that's a conscious design decision. The reason for that is that many of you use tools like DSM1 copy to move data from one system to another, and therefore it's very important that the number of partitions in a UTS PBG table space is the same in both systems. But for those people who do want to contract back the number of UTS PBG partitions, this is a very nice new option. The last point to say here is there is no support for point-in-time recovery to a point prior to the switch phase for a table space that's just been pruned. Now let's turn to slide 44. On slide 44, I'd like to talk about enhancements to run stats and real-time statistics. When you do a load, replace, or reorg, as a user you have the option to either collect inline run stats or collect separate run stats immediately after the load or the reorg operation. And I'm simply pointing out, if you compare the values collected for inline run stats versus the separate run stats, there may be some differences, some noise, but it's unlikely to be significant. Next, it's now possible to avoid the DSNU 602I message when you're running reorgs at the part level. This message can now be avoided if you're either using the sort NIPSI option on the reorg part job, or you run the reorg part job when the ZPalm reorg part sort NIPSI is set to either auto or yes. And the second condition is that internal thresholds are exceeded, and reorg will sort all of the non-partitioning index keys based on that amount of data, and therefore avoid this condition. There's a new option on run stats called reset access path, and this is a very useful command to wipe out the existing run stats and set them back to default values. This could be useful in the situations where you've got missing some particular run stats, or there's conflicting run stats, or you don't trust the values in the catalog. This reset access path option does not affect the space statistics in the catalog or in RTS. Also in version 11, we now avoid the DSNU 1363I message. This is where you're trying to run a run stats profile, and a profile for that table does not exist. This message will no longer come out, and DB2 will use fixed defaults. The run stats profile is still not available when you're running inline statistics in both reorg and load. And the final enhancement on this slide is in new enhancements to the access database command called mode stats. And this gives you as a user the option to force out and externalize the RTS in-memory control block information out to the RTS tables. Now let's turn to slide 45. On slide 45, I'd like to talk about major enhancements to the recover utility. Way back in version 6 of DB2, DB2 implemented fast log apply for recover table space. Now fast log apply has been implemented for a recover index. Previously, DB2 would wait until a log record was to be applied and then read the associated index page into the local buffer pool where it was then cached. Now DB2 will use list prefetch to read all those index pages associated with log apply into the buffer pool, and to do this before the log record is to be applied. This has potential for significant savings in elapsed time. Now this may lead to the situation now where you may decide to consider using copy and recover index as opposed to rebuild index in recovery situations. The disadvantage of rebuild index is that you can't issue rebuild index until all the partitions of a partition table space have been recovered. On the other hand, when you've got index copy recover, you can recover the index in parallel with the table space, and in fact, you can recover the index and the table space in the same job. This is such an important enhancement that this was also taken back to version 9 and version 10 via the APPLCOMPAT-Application 07694. And the last item here is an optimization related to point-in-time recovery of a list of objects. What will happen here is that when you run the recover under diagnose type 607, DB2 will only recover objects where necessary. In other words, if there are no updates between the 2 log point and the 2 RBA in currency, then there's no need to actually do a recovery. Now let us turn to slide 46. Before beginning the live Q&A, I'd like to make a couple of announcements. First of all, part 2 of this webcast will happen tomorrow at 11 a.m. Eastern Time. And I'd also like to advertise a new webcast on the 30th of June. And the subject of that webcast is going to be opportunities of using large real memory with DB2 10 and 11 to reduce CPU resource consumption. Now let me hand the session over to the moderator.